In this quick video, I'll be taking you through 3 of the medium circle geometry exam questions from this higher paper. We also have videos teaching this exact topic, along with easy and harder exam questions. So in this question, we're given that A, B, C, and D are all points on the circumference of a circle. We're also told that BED and CEA are both straight lines. And the final piece of information is that CE and BE are of equal length. That just means that this triangle right here is an isosceles triangle, so that this angle and this angle are equal. Now, the whole point of this question is to prove that AC is not a diameter of the circle, and we prove this by using one of the circle theorems that say that the angle made from a diameter, so this angle right here, should be 90 degrees, and if it's not, then this length right here is not a diameter. So to get this angle, I'm going to start off by calculating this small angle right here. And to calculate the base angles of an isosceles triangle, you subtract this number away from 180 degrees. So we have 180 degrees minus 52. And because this angle and this angle are both equal, we're going to divide that by 2. So dividing by 2, and that gives us an answer of 64 degrees. So we know that this angle right here is 64 degrees, and this angle right here is also 64 degrees. And to get the rest of this angle, we need to calculate this small one right here. I've noticed that if I draw a chord right here connecting A to D, that splits the circle into a minor segment here and a major segment right here. And that means that this angle and this angle are both in the same segment. And we also know that both of those angles are made from the same chord. And using one of your circle theorems, that means that this angle and this angle must be equal. So this angle must be 30 degrees. We just need to add 64 and 30 together to get this full angle. So 64 degrees plus 30 degrees is equal to 94 degrees. And like I said before, if AC was a diameter, then the angle right here should be 90 degrees. But we got 94 degrees. And 94 degrees is not 90 degrees. And the conclusion we draw from that is that AC cannot be a diameter of the circle. And that was a brief explanation of the proof, but if you want full marks in an exam, you would write these 3 points down, making sure to give a reason behind each stage of your working. Pause the video if you need time to write that down. Other than that, that is the end of this question. This shape right here is a cyclic quadrilateral, and that's because all 4 corners are touching the circumference of this circle right here. We're told that the ratio between x and y is the same as the ratio between 3 and 5. And we're asked to work out the size of angle z, which is right here. One of the circle theorems you need to remember is that opposite angles in a cyclic quadrilateral add up to make 180 degrees. So if we take x and y and add them together, so x plus y, they must equal 180 degrees together. And because we have a relationship between the ratios of x and y, we can work out the individual value of x or y from this equation right here. So we need to split 180 degrees into the ratio of 3 to 5. And we do that by dividing 180 by the total amount of parts. In this case, we have 3 parts here and 5 there, for a total of 8 parts together. So 180 degrees divided by 8 gives us a value of 22.5 degrees. And remember, this is the value of 1 part. We know that x is worth 3 of the parts, or y is equal to 5 of the parts. So the value of x is equal to 3 multiplied by 22.5 degrees. And that's because x is worth 3 parts, and 22.5 is the value of one of them. Working that out gives us an answer of 67.5 degrees. So we now know that this angle right here, x, is equal to 67.5 degrees. We could work out y by multiplying 22.5 by 5, but we don't need it to work out the value of z. And that's because to work out the value of z, we're going to use this angle right here because they're opposite using the exact same circle theorem we used before. So to work out this angle, we're just going to add 30 to 67.5. And 67.5 degrees plus 30 degrees gives us an answer of 97.5 degrees. So this angle is 97.5 degrees. And like I said before, z plus this angle is equal to 180. So z plus 97.5 is equal to 180. And because we want the value of z, we're going to have to minus this 97.5 away. So minus 97.5. And because we did this on that side, we're going to do the same on this side as well. So also 97.5. 97.5 minus 97.5 cancel each other out, leaving us with a z on the left side. And 180 minus 97.5 gives us an answer of 82.5 degrees, and that is the value of z. I've explained the reasons behind all of my working, but to get full marks in an exam, you need to write these 3 points down. Pause the video if you need time to write it down, otherwise that is the end of this question. So in this question, we're told that B, C, and E are points on the circumference of a circle. We're told that AED is a tangent to the circle. We're told F is the center of the circle. And we're told what this angle is and what this angle is as well. And if we scroll down a little bit, the question wants us to work out the angle of CEF. CEF, so this angle right here. So I'm going to mark that angle as X. Now, the alternate segment theorem says that the angle made between a tangent and a chord, so this angle right here, is equal to the angle that's made from the chord. So the angle made from this chord is this angle right here. So that means because this is 56 degrees, this also has to be 56 degrees. Another circle theorem we know is that the angle at the center is twice the angle at the circumference. So this angle right here is 2 times 56, which is 112 degrees. And another circle theorem we know is that two radii, so this radius and this radius right here, form an isosceles triangle together. And that just means this angle and this angle are equal. So the two radii are of equal length, so I'm going to draw a dashed line to signify that. To work out the base angles of an isosceles triangle, you subtract this number right here away from 180. So 180 degrees minus 112 degrees. And because both angles are equal, we divide by 2, which gives us an answer of 34 degrees. So we know that this is 34 degrees and this is also 34 degrees. So we've got so many different angles on this diagram, but the only one we want is this X. And the last thing I notice is that this right here is a triangle within the circle. And that just means this angle plus this angle plus this angle must equal 180 degrees. So we have X plus 34 plus 34 plus 35 plus 56, and we know that's equal to 180 degrees. If you add all of these numbers together, you get an answer of 159, and then of course we still have that plus X, so X plus this, and then it's still equal to 180 degrees, so we equate that to 180. To get X, we just subtract this over to that side, so X is equal to 180 degrees minus 159, and that gives us a final answer of 21 degrees. I've explained all of my working in words, but if you want full marks in an exam, you're going to need to write all 5 of these points down. Pause the video if you need time to write it down. Other than that, that is the end of this video.